be talking about Bernoulli's principle and how it involves flight. People have always understood that flight is possible by observing the birds. Some of the greatest people that have been in airplanes, like the Wright brothers, watch the birds and learn from them how they do it. But over thousands of years, there's been plenty of hurdles that people have had to go and jump through just to be able to make manned flight possible. What are some examples that include flight? Planes, birds, balloons, etc. Anything that you see in the air pretty much is considered flying. Flight is defined as a controlled movement through air and includes sustained, controlled, and powered flight.
Alright guys, now we're going to take a look at something called wings, airfoils, and the forces of flying. Now, to take a look at these, we can look at birds and planes. These are two really great examples of flying objects. Now, the wings of birds and planes have a very similar characteristic, which is their airfoil shape. An airfoil shape lets us overcome weight, which is the effect of gravity pulling down on an object. The airfoil shape gives us something called lift. Lift is the upward force required to overcome gravity by a wing's shape. This action allows the plane to move upward and forward through the air. Okay guys, now we're going to talk about drag. Drag is something that slows us down and is the resistance to airflow and slows the forward progress of the plane. Thrust is the force required to overcome drag and provide speed for the wing to create lift and actually take off. This must be provided by an engine or by muscles for a bird.
Alright, now we're going to talk about how we control flight and how we actually control the airplane or how a bird controls itself. Controlling an aircraft is on three axes. It's yaw, pitch, and roll. Movement of these parts such as the rudder, elevators, and aileron control the movement of the airplane or the bird and control its flight path. The rudder controls the yawing, which is the left or right motion of it moving. Elevators control pitch, up and down, and ailerons control rolling.
Now we're going to talk about the actual Bernoulli's principle. Bernoulli's principle explains why an aircraft can create lift. First off, the shape of the wing allows for the air moving over the top part to be faster while the air under the wing moves a lot slower. This creates a pressure difference between the top and bottom of the wing. This is the basis behind Bernoulli's principle and allows the high pressure on the bottom and the low pressure on the top to push the wing up and create lift. Alright guys, now I'm going to explain the Bernoulli's principle. This looks long and scary at first, but it's very easy to break down. First we have this P. This is the atmospheric pressure that's pushing down on the system. This atmospheric pressure is different based on what your wing shape looks like. Next you have this whole quantity. This is like potential energy. So what this means is you have the symbol for density of the air, and then you also have G, which is gravity, and H, which is height. This is the potential energy, so the more that you have, the higher the system will go. Next is this whole quantity, which is like kinetic energy. This again has its symbol for density, and it also has a velocity component in there. This also shows why airplanes can move faster, or the particles move faster over the air, or over the wing, because it allows for the particles on top to move faster than the particles on the bottom. All this is equal to the same thing, but it has different numbers. So what this means for an aircraft is when your atmospheric pressure changes, that means that there's higher pressure on top and lower pressure on the bottom, and this is what creates the lift from the H. And then you also have the velocity, which again, it has faster particles moving over the top and slower particles moving on the bottom.
Alright, so today we've learned about Bernoulli's principle and how it affects planes, birds, and any object that we see in the air. Bernoulli's principle has explained how an aircraft achieves lift and how a bird flies. Bernoulli shows us how airfoils are used and how they use pressure and how it affects it, and how birds achieve lift and how airplanes and anything else achieves lift. Bernoulli's principle is everywhere in our society. No matter if you walk right outside your door, something will be affected by Bernoulli's principle, and it's simple to understand. And I hope you enjoyed how Bernoulli's principle works and how we explained it.
Alright guys, now I'm going to show you a quick experiment that I knew for Bernoulli's principle. First off, we see that there's a water bottle right here. What you can't see is that there's a little tiny hole right here. What I'm going to do is that you see that no water's flowing out even though there's a little hole. When you take off the cap, water's going to start spurting out of it. When you put the cap back on, it'll stop. You can then take it off, put it back on. Why this happens is because that right now the atmospheric pressures are all the same inside the bottle and down here, but when you take the cap off, the pressure changes and it causes water to flow out of the bottle.